All right, welcome. Today we're going to dig into the real building blocks of all code. And to get started, I've got a little puzzle for you. It looks super simple on the surface, but it actually reveals a huge secret about how computers, well, how they think. Okay, let's kick things off with something a first grader could solve in their sleep. 5 plus 5. Simple, right? We all know the answer. But the real question is, what does a computer think the answer is? Yep, exactly what you'd expect. 10. No surprises here. The computer sees two numbers, it does the math. Easy peasy. Okay, but what if I write it like this? It looks almost identical, but do you see those little quotation marks around the fives? Now to you and me, that's a tiny detail. To a computer, it changes everything. And boom, this is what you get. 55. Wait, what? Not 10? The computer didn't add them at all. It just smushed them together, side by side.
So that's the big question, isn't it? Why in the world do we get two totally different answers for what looks like the exact same problem? This, my friends, is the puzzle of data.
And the answer to that puzzle is a concept called data types. Honestly, the best way to think about them is like different Lego bricks for information. Before a computer can do anything, it has to know, am I working with a number brick, a text brick, or something else? The type of brick determines what you can do with it. So let's start with our first type of building block, the one that explains that weird 55 answer. We're talking about strings, a fancy name for the text blocks of the coding world. A string, or str for short, is really just a sequence of characters. It's how computers handle pretty much anything that's text. You can put anything in a string, a single letter, a word, a whole book, you name it. The key rule, it's gotta be wrapped in quotes. That's the signal to the computer that it's looking at text. Oh, and here's a cool little detail. Strings are what we call immutable. That just means you can't change a string once it's made. You have to create a whole new one to replace it. This is exactly what happened with our 5 plus 5 puzzle. The computer saw two text blocks, and the plus sign for text means stick these together. That's it. It's a process called concatenation. It's the same logic we see here. You take a blog title, you add by, you add a name, and you get a complete sentence. All right, let's move on to our next building block. If strings are for text, then when we need to count things, we use integers. An integer, or int, is pretty much exactly what you learned in math class. It's a whole number. Could be positive, negative, or zero. The key is no fractions, no decimals, just simple, clean, solid numbers. These are the absolute workhorses for anything you need to count. Think about things like quantities or a unique student ID. And here's a fun fact. Modern computers can handle integers that are mind-bogglingly huge, basically limited only by how much memory the computer has. So, let's circle back to our original problem. When the computer saw 5 plus 5 times without any quotes, it immediately knew, aha, these aren't integer blocks. And for integers, the plus sign means do the math, just like you would to figure out that 7 times 4 gives you the total days. But what happens when you have numbers that aren't whole, numbers with decimal points? Well, for that, we need our third and final building block for today, floats. I kind of like to call them the measuring blocks. A float, or a floating point number, is just any number with a decimal point, and the name is actually pretty cool. It's because the decimal point can float around to represent numbers of different sizes and precision. You're going to use a float for anything that needs precision. Think measurements, money, or a GPA. But there's a really interesting little quirk with floats. Sometimes they can have these teeny tiny precision errors. I mean, calculating a price after a discount, perfect example, or storing a GPA like 3.85. In these cases, you absolutely need decimals, and that's what floats are for. They handle it beautifully. Well, almost all the time. Yeah, because that little note I mentioned about precision errors, it's a bigger deal than you might think. Floats have this little secret that trips up pretty much every single person when they start coding. So let me ask you a super simple question. What is 0.1 plus 0.2? Come on, you know this. It's 0.3, right? 3/10. Obvious. Well, ask a computer, and this is what you're likely to get. It is so close to 0.3, but it's not quite there. See that tiny little 4 hanging out at the very end? What is that about? Okay, don't panic. Your computer isn't broken. This isn't a bug. It's actually a famous quirk of how computers work. It all comes down to how they have to translate our decimal numbers into their native language of ones and zeros. It's a really fascinating detail that shows you how deep this stuff can go. So there you have it, our 3 fundamental building blocks. So how do you know which one to grab? Let's do a quick little side-by-side to make sure it all sticks. Okay, let's break it down one last time. Simple, if it's text, a name, a message, whatever, you're going to use a string. If you're counting whole things, like your age or how many items are in a shopping cart, that's an integer. And if you're measuring something that needs that decimal point, like a price or your GPA, you reach for a float. Choosing the right block is honestly the very first and maybe most important step in telling the computer exactly what you want it to do.
And that's it. Strings, integers, and floats. They really are the absolute bedrock of all programming. Seriously, everything you see on a screen, websites, apps, video games, it's all built on top of these simple ideas, these fundamental blocks. So now that you know them, what will you build?